In this video, we're going to look at another example of using the chain rule to differentiate a given function. And in this case, we're given a special kind of function called a Gaussian function, which it has many different uses as we saw inside of the problem in the context of our problem. But what we're concerned with is not necessarily the uses of it, but we want to know how can we use the chain rule to differentiate something like this. And we see that we have some coefficients here and some constants that are undefined as of right now, but they're given values inside of our problem. So the first step of this process is going to be substituting in the a, b, and c values that were given into this equation to know what we're dealing with. So here we would get ae would turn into 4e raised to negative x minus a negative 1 is going to turn into plus 1. This is all squared over 2 times c squared, which is 1 squared, or 1, so 2 times 1 is just 1. So this is our function, and this is what we're dealing with for the context and the remainder of this question. Well, now we're asked, what's the first derivative of this? How can we find that? And just as I said in kind of the preface of this video, we're going to need to use the chain rule. And the reason for that is we see that 4 is a constant multiple, so we can kind of leave it off for the time being of finding our derivative. But we see that e is a function being raised to some other function inside of its exponent. So when we have a function composed of another function in this manner, we need to use the chain rule to differentiate it. And more specifically, what I'm going to use is the Newton form of the chain rule. So let's go ahead and make a note here. It's going to be chain rule, and we're going to use the Newton form. So let's go ahead and set up our table to take the derivative of this equation with our Newton form. So here our outermost equation is the one we're going to write first, which is e raised to something. And in this context, when e is raised to something, the derivative of that is e raised to something. And more specifically, if we come over here and we define e to the u prime, where u is some function that e is being raised to, the derivative of that is still going to be e to the u, but times the derivative of whatever happens inside of this power. So that's what we're going to find in this case here by using the chain rule. Well, what is that something that we're raising e to? We have negative x plus 1 squared over 2. Okay? And then we get to this and we kind of ask ourselves, well, how can we find the derivative of this very readily? Well, let's go ahead and use, again, the chain rule on this, because we have a function, this exponent of a square here, affecting this function that we have inside of the parentheses. So in order to define this derivative, let's use another set of the chain rule. Okay, so here's what we have. We have, and again, this negative 1/2, I'm going to go ahead and write this down before we get too far into this. This negative 1/2 is a constant multiple, okay? So whenever we bring negative 1/2 into it, it's going to happen in the sense that we can do something like this. I want to keep it here so I don't lose it because it gets a little bit hectic as we go along. So this negative 1/2 is multiplied by this expression with this square here. So when we do this first function, we're going to define as negative 1/2 times that thing inside, which we said our second function was x plus 1, and this whole thing is squared. So taking the derivative of just this part of it right here, we're going to use the power rule. We're going to bring this 2 down, multiply it by negative 1/2, so these 2's will divide away, and the power that we're left with is 1 in the top, right? So here what we're really going to have is this is going to equal negative whatever goes inside of that. But first, to finish off our table, what's the derivative of this? It's just 1, okay? So as we use the chain rule to figure out what our derivative of this is, we're going to use whatever we have here, this negative, and in this blank space, we're going to put x plus 1, the original function of our inside. So here we have negative x plus 1 times the derivative of what was inside, which is 1. So our derivative is negative x plus 1. Or you could equivalently call it negative x minus 1. Either way, going to represent the same thing. I'm going to keep it in this form for the time being, though. So we have this. So we know that our derivative of this right here is x plus 1. When we go back to the context of what we had earlier, this that we found here is the derivative of the function on the inside of our composition. Namely, it was the power that e was being raised to. So here again, we're going to kind of follow the same pattern that we just did up here or over here to figure out what our derivative of the power was in order to find out what our derivative of this is. So we have e being raised to this thing still. So let's go ahead and make a note here. So f prime of x. Before we get too much farther, let's not forget to write that 4, that constant multiple there. Let's keep track of that. But we have e raised to this thing still. That doesn't change. So we have 4e raised to negative x plus 1 squared over 2. So this is our first part of it, e being raised to the original inside function, but then we multiply this whole thing times negative x plus 1. Okay? And then at this point, we could go off and do some simplification of this. We could multiply this 4 into this term here and do all that kind of good stuff. But in order to kind of keep the work simple for us, we're going to go ahead and skip over that part for the time being and move on to finding our second derivative of this, because it's going to involve a lot of the same process that we just went through with using the chain rule. But now that we have a derivative defined as the multiplication of two functions, we're also going to have to bring in the product rule. So when we bring the product rule into the mix, the question gets a little bit more interesting to deal with, but it's nothing that we can't handle. So when we find the second derivative of this, we need to take our first derivative and derive it again, right? But we see that 4e raised to this is one function, and this is another function. So let's call this g, let's call this h. So our second derivative is going to take the form g of x times h prime of x plus h of x times not h of x, g prime of x, my fault. And we have g prime of x. Okay, so I'm going to go ahead and fence this off so we know that what we're dealing with here. So I'm going to scroll down so we have more room to work as well. So this is what we're looking for our answer to take the form of. I want to try to keep f prime of x in the frame because that's what we're taking the derivative of. So when we talk about using the product rule, I'm going to come over here and write out what we have already and what we need to find. So we know that g of x is 4 times e raised to the negative x plus 1 squared over 2, and h is negative times x plus 1. Okay, well h prime is kind of easy to figure out, right? Because we said that this could also be written as negative x minus 1. So if we distribute that negative back in there, we get negative x minus 1. And what's the derivative of negative x minus 1? Just negative 1. Okay, so we found our derivative of h. What's our derivative of g? Well, if we hadn't already done all this work up here to find the derivative of 4e raised to the negative x plus 1 squared over 2, namely being this whole thing, we would have to do a lot more work. But since we already did that, we're simply going to rewrite it down here so that we don't have to keep referencing it from up top because we already did the work. So we have 4e negative x plus 1 squared over 2 times negative x plus 1. So this is our derivative of our component g right here. So plugging this into our f double prime form that we have here, f double prime of x, let's just plug this in piece by piece. So g is 4e raised to the negative x plus 1 squared over 2. That's our g. And then h prime is negative 1. So I'm going to skip down here and say, okay, let's multiply this right here. So we have negative 1 times 4. We have this going on. Okay? And so we've taken care of the first multiplication in our product rule. Now we got to take care of the second. So this is being added to h of x, which we said was negative x plus 1 times our g prime of x, or this whole thing. So we get 4e negative x plus 1 squared over 2 times negative x plus 1. So it can get sort of confusing here, writing in all these terms and not being and wanting to multiply this stuff out and kind of make it easier to read. And it's going to become more of a chore to plug this stuff into WebWork to find your answer in this correct format, but I would highly recommend using the preview my answer option to plug this in first before you try to submit it, just to make sure you've typed in the right thing you have to type in, because it's going to deal a lot with parentheses in the answer being raised to certain exponents, being multiplied by in different negatives, what have you. So I would highly recommend following that step in this regard. But what we can do to kind of make this simpler on ourselves is we see that there's a negative here in this multiplication term and a negative here, but there's not one here. So we can go ahead and factor that negative out, and what that leaves us is x plus 1 times x plus 1 times another negative 4e raised to the negative x plus 1 squared over 2. As long as you type in an answer equivalent to this that we have here, WebWorks should accept it, and it doesn't matter kind of the order that these are in, as long as you have the correct signs attached to the correct things and the correct multiplications, the correct parentheses, what have you. So if your answer has all these ingredients just in a different form but in a correct way written, you should be okay. But if you get error messages, check your parentheses, check you have all the components correct, check your math, make sure you didn't drop a negative or a constant multiple that we had going wrong in the mix, anything like that. But your answer should come to the form that looks something like this in the case where we have it, where we were given the values for A, B, and C that we have using the chain rule and the product rule. But your answer should take a form that is very similar to something that looks like this, and it's going to kind of vary from question to question based on the A, B, C values that you have. But what's going to remain the same is that in the first derivatives case that we talked about, you're going to need to use the chain rule, maybe more than once, like we did. And then in the second case, you're going to have to use the product rule. But luckily, whenever we talk about the product rule, we can use the result we got from the first derivative in the answer for in the process to get our answer for the second derivative. So it works out really nicely.